Here in example C, they are factoring the trinomial of the form 4x squared minus 4x minus 15 using a guess and check method. The biggest part that differed here from examples A and B is in examples A and B, that leading coefficient was prime. Here in example C, and all these examples we're about to see, A is not prime. It has, it's considered a composite. It has more than two factors. So we have to take that into account when we go to create. Again, I'm going to use the graphic organizer because I feel like this gets very tedious after a while and can get kind of messy in my opinion. So I would rather write things down in pen/pencil and kind of erase. So I would strongly recommend not doing these in pen. So we're going to dive into the try these C. We're going to start with letter A. Letter A says 6x squared minus 11x minus 2. Okay, so again we have 6 and 2. Now we're in luck. Even though A is not prime, C is prime at least. So this can only be 1 and 2 in those combinations here. We don't know which one's positive or negative because it is a -2 we're trying to get to, but it at least eliminates some possible choices. Here, this could be 1 and 6 or 2 and 3. So I'm actually going to go ahead and create my graphic organizer. In this top left box, I'm going to put in 6x squared. In the bottom right, I'm going to put in -2. Now, we know that these have to be 2 and 1. I don't know in which order, but they're set. One's going to be positive, one's going to be negative. I can go back and add and change that as I need, but at least I know that they are 1 and 2. I know along the diagonal, I want to get a -11x. So we're going to have an x term here and an x term here. Okay? So we're going to kind of play around with these combinations here. Now, because I know that one is positive and one has to be negative in order to get this -2 here, I know that I am actually subtracting these two terms that are on this diagonal. This is definitely going to be a subtraction. Okay, well, let's try this. We could do 1x here, 6x here, right? Well, if I do 1x and 6x, that would make this 12x, and that would make this 1x. If I subtract those, could I get a -11x? Yes, I could. Okay. Which one has to be negative? The 12, you say, right? This has to be negative in order for this to be negative. Now, either the 2 or the 1 was negative, because that was the term that's negative here. So it would obviously have to be the 2. Just so happened that we tried the right combination to start off with. This would be x minus 2, 6x plus 1. Just so you know, there will only be one combination that works. So this is going to be 6x plus 1, x minus 2. Let's take a look at B. We have 6x squared minus 13x minus 4. All right, we're not as lucky here because neither one of these are prime. But I know I've got 1 and 6, 2 and 3, and this can either be 1 and 4 or 2 and 2. We're going to have 6x squared here in the top left. In the bottom right, we have our last term, which is negative 4. Okay, I know that I'm going to have an x and an x. And on this diagonal, we're looking for a negative 13x. I also know that because this is negative, these are going to be opposite signs. So this will be a subtraction. Notice I am not setting anything else in pen at this moment because I have 2 options here and 2 options here. So both of those can be interchangeable. Okay? Let's start off with putting our 1x and our 6x here. Okay? I could either do 1 and 4. If I do that, that's going to give me 6x here and 4x here. If I subtract those, I am not going to get negative 13. Okay, let's change these around. Let's make this a 4, and let's make this the 1. If I switch those around, I get 24x and 1x. If I subtract those, I am definitely not going to get negative 13. Okay. Let's try the 2-2 combo here with the 1-6 where we have them. 2, 2. This is going to give me 12. This is going to give me 2. If I subtract, I get 10. Now, notice that if these are 2 and 2, it doesn't matter what order I put them in. The multiplications are still going to be the same. I'm just going to subtract. Okay? Well, we know that the 1-6 combo doesn't work. 1-6 doesn't work. Let's try the 2-3 combo then. We know that 3 times 2 is going to give us 6 here. 2 times 2 is going to give us 4. If I subtract those, I get 2x. Not going to cancel. Okay. Doesn't matter if I switch these. They're still going to be the same combination. So let's go back to I know the 2-2 combo doesn't work. Let's try the 1-4 now. Got the 1 here and the 4 here. This is going to be 3. This is going to be 8. When I subtract, that gives me 5. Doesn't work. But I can reverse these because these numbers are not the same. So let's put the 4 here and the 1 here. Okay. This gives me 12. This gives me 2. When subtracted, I get 10. So the 1-4 combo didn't work, and neither did the 2-3. What do we have here? None of these factored to that negative 13x in the center. So this would be unfactorable. All right, let's look at C. C is 4x squared minus 20x plus 21. So I need factors of 4, factors of 21. So this is going to be 1 and 4 or 2 and 2. This is going to be 1 and 21 or 3 and 7. Go ahead and draw my graphic organizer. Top is going to be 4x squared. Bottom is going to be 21. I know that I'm going to add, I'm going to add these along the diagonal, and I'm going to get negative 20x. Now, the problem is with the first term and the last term both being positive, I know that my factors have to be the same for this second term. That 21 have to be the same. But because b is negative, that means both of those factors are negatives. So I'm going to have a negative number and a negative number. I do know that. So this is negative, this is negative. I know they're both going to contain an x. And we are indeed, because both of them are negative, we will actually be adding that diagonal. Okay. Nothing is set in stone because none of these terms were prime. So we're going to have 4x and 1x. Let's try that to start with. And let's try the 121 combo. Well, 4 times 1 is 4. 21 times 1 is 21. That's going to give me 25 when I add those. That doesn't help me. Let's switch that order. Let's put the 21 here and the 1 here. Well, that makes this 1x down here. And that makes this 48. When I add those, again, I am not getting 20. Okay. So I know that the 1,4 and the 121 cannot be a combination together. Not saying that 121 doesn't work. Not saying that 1,4 doesn't work. I just know that they cannot be combined together. So let's go to the 3-7 combo here on the constants. Let's put 3 here, 7 here. Well, 3 times 4 is 12. 1 times 7 is 7. That gives me 19 on that diagonal. That doesn't help me. Let's switch those around. Let's make this the 7, this the 3. This gives me 28 and 3. That's too big. Okay, so what I have found out is that the 1-4 combo doesn't work with either the 121 or the 3-7. So 1-4 is definitely not the right combination there. So these, if they're factorable, it has to be 2x, 2x. So let's try it with the 121. This would give me 2x and 42x. That's not 20 when I add these together. Okay, so I know that 121 is obviously too big. Let's try the 3-7 combo here. All right, 2x times 3 is 6. 7 times 2x is 14. When added together, these do indeed give me 20. So the correct combination here is 2x minus 3, 2x minus 7. So again, that was 2x minus 3, 2x minus 7. Go ahead and take a moment to get this copied down. Again, I still feel like the graphic organizer would be easier than going through all these guess and check possibilities here. I feel like this is a little bit more organized, and it's easier for me to erase smaller things than to try to rewrite this over and over and over again. So the biggest thing we need to do is I always identify are factors of A and C. Go ahead and take this down, and then we'll move on to example D.